My topic is arithmetic mean and its various forms with problems. This topic is related to statistics. I am Archana Sharma from Government Polytechnic Colleges. So, I will give lecture on arithmetic mean and its various forms. First, arithmetic mean, that is part of center tendency. This is often used to report center tendencies. Now, statistics is described as a mathematical body of science that pertain to the collection of data. First part is of statistics is collection of data, then analysis it, arrange it, interpret what this data says, or then explanation, and then its presentation of data either in form of graphs or charts. Now, statistical method can summarize to describe a collection of data. Now, in course of statistics, we will describe how to part of it interpretation. Now, part of statistics is measure of center tendency. Now, to analyze the data, to make the data comparable when there are two data, to compare that data and to analyze it, we reduce the data to a single value. The whole data is reduced to a single value, that is called measure of central tendency. So, this is the single value which represent the whole data. However large the data, we represent it by a single value. This single value is called measure of central tendency. This is also called center value or average value. I have learned that average of a data or average of a value. So, measure of center tendency, you can say it as central value, you can say also as average value. Now, parts of measure of center tendency. To measure the center tendency, there are three methods: mean, median, mode. In mean, we come up with the single value, that is we add all the values and divide by total number, then it becomes mean. For median, we take the value which divide the whole data into two equal parts. Half values are above the median and half values are below the median. So, this is the perfectly center value. Mode. Mode is that value which appear frequently in the data. Maximum time which value appear in the data, that is called mode. So, we can measure center tendency in three ways: mean, median, mode. But in this lecture, we will discuss mean. Now, mean is further is of three types. One is arithmetic mean, second is geometric mean, third is harmonic mean. In this lecture, we will study only arithmetic mean. Now, arithmetic mean, we call it AM, that is short form of arithmetic mean. Arithmetic mean is the most common measure of center tendency. We have learned that there are three ways of measure of center tendency. One is mean, median, that is mode, but arithmetic mean, that is the most common measure. If it is simply, how we calculate mean? Simply sum of the numbers divided by the number of numbers. How many numbers? We count the numbers. First we add, this is summation x, we will all values of x. If the data is of marks of students, then we all add all the marks, and then n mean number of observations, number of counting, if number of students, number of laborers, whichever data. So, mean is sum of all values divided by total number of observations. This is the simple way. What mean is the sum of all values divided by total number of observations. arithmetic mean of, if there are n observations, then arithmetic mean of an observation of variable x. Variable x is depend upon data, of which data is given, data is of number of children, that is of height of children, that is of marks obtained by children, or data is of wages, whatever form. Then this is the variable. Then first we denote it by m, then arithmetic mean is equal to sum of all values. If there are an observation, say x1, x2, x3, xn, then we add all these values and then divide it by number of observation. We call it summation x, that is symbol of summation. Summation x means sum of all values of variable x and divide it by number of observations. If the mean is equal to summation x by n, summation x means sum of all values. In case we know median and we know a number of observation and we have to find sum of all values, then we can find sum of all values as summation x is n time m, that means n number of observation, m is mean. If we multiply number of observation with mean, we can find sum of all values in the data. So, if we have given mean, we have given number of observations and we have to calculate sum. So, this is the way summation x is equal to n time m. Now, take example. Suppose we have 5 numbers 1, 2, 3, 6, 8. Now, and we have to find mean. Then mean of these numbers are 1 plus 2 plus 3 plus 6 plus 8, and then divide it by count number 1, 2, 3, 4, 5. So, divide it by number of observations. So, this addition is equal to 20, now divided by 5, that is equal to 4. So, 4 is the value which represent this data. So, the 4 is mean of this data. So, 4 is the measure of center tendency. In this lecture, whenever we say mean, it is assumed to refer to it as arithmetic mean. In short, we always say mean. One example, find arithmetic mean of first n natural numbers. N natural number, you know, 1, 2, 3, 4, 5 up to n, and can be any number 10, 15, 20, 22, any number. Now, arithmetic mean of first n natural number. How do we find arithmetic mean? Add these numbers 1 plus 2 plus 3 plus 4 up to n, whatever n is given, and divide it by total number of value. If 1 plus 2 plus 3, this is also counting numbers. So, there are number of observation is n. Now, first we have to find 1 plus 2 plus 3 plus 4, this addition up to n. Now, this addition is equal to, this is from an AP. This is AP series with first term 1 and common difference also 1. So, it sum up to n into n plus 1 divided by 2. Now, substitute this value, n into n plus 1 divided by 2 divided by n. N will cancel each other, then we come up with n plus 1 by 2. So, arithmetic mean of first n natural number is equal to n plus 1 by 2. Now, next question is, if arithmetic mean of this 8 number is 7, find x. We have given arithmetic mean and we have to find x. Now, again arithmetic mean is 7 plus 9 plus 5 plus 2 plus 4 plus 8 plus x is equal by 7. Now, this arithmetic mean is also given as 7, because these are 7 numbers counting 1, 2, 3, 4, 5, 6, 7, and mean is also 7. So, 7 is equal to 35 plus x by 7. Now, simplify it, 35 plus x is equal to 49, and we come equal to x equal to 14. So, this value, unknown value is 14. If we take x is equal to 14, its arithmetic mean will be equal to 7. Combined means some time we have given two groups mean and we have to find combined mean. Now let's take if M1 is mean of group of N1 observation, M2 is mean of group of N2 observations. There are N1 observations whose mean is M1 and there is N2 observation whose mean is M2. And we have to find combined mean, that means mean of these two groups. Now number of observation of these two group is first is N1, N2. So number of observation is N1 plus N2. Now we have to find sum of observation. In first group sum of observation is N1, M1. In second group sum of observation is N2, M2. So we have it. So combined mean is sum of observation is N1, M1 plus N2, M2, and total number of observation is N1 plus N2. So combine, whenever we have to find combined mean, we take this formula, number of observation into its mean plus number of observation into second mean divided by sum of observations. This formula you can extend up to any number of groups. This is formula here given for 2 groups. You can extend it to more than 2 groups, 3, 4, 5, anyone. No problem of combined mean. Suppose in a class the mean height of 20 boys is 160 centimeter. Is given mean height of 20 boys, 5 boys, number of observation is 20 and mean is 160 centimeter. And that means mean height of 30 girls is 150 centimeter. That means here number of observation is 30 and its mean is 150 centimeter. We have to find the mean height of 50 students. No, there are 20 boys and there are 30 girls. Total number of students are 50. We have given mean of boys, mean height of boys and mean height of girls. We have to combine these two students. So here number of N1 take number of boys 20, N2 take number of girls 30, M1 take mean height of boys 160, M2 mean height of girls 150. So combined mean height is number of observation into mean plus number of observation into mean divided by sum of observation, that means 20 plus 30. Now we multiply it and then add it, 20 into 160, 30 into 150, multiply and then add. We come up with 7700. This is sum of observation divided by 50. This is number of observation. After dividing we will get 154 centimeter. That means combined mean height of 50 students is 154 centimeter. Whereas mean height of boys is 160 centimeter, mean height of girls is 150 centimeter, but mean height of combined students is 150 centimeter. Next example, the mean marks of 100 students are 40. Suppose if a value is changed from 35 to 75, if there is given number of observation and there is given a mean, but we have to change one value. Suppose this value we have added is 35, but no, we have to change it to 75. Then how to find new mean? Now first for old mean, n is 100 number of student and its mean is 40. Now first we find sum. So we know mean is equal to summation x by number of observation. So 40 is equal to summation x by 100. So summation x is equal to 40 into 100, that means 4000. That is sum of all observations of marks. Now we have changed 35 to 75. So new summation x, new sum of marks is 4000. We have changed 35. So with subtract we have add 75. So we will add this. So we come up with 4040, subtract 35 and add 75. So new summation x is 404. Now new sum of marks is this. So new mean is equal to sum of marks and number of observation. So number of observation is same as previous 100. So summation x by n is equal to 40.4. This question, algebraic sum of deviation of all variate from their mean is 0. that says when we subtract mean from all observation and then add, then sum will be always equal to 0. That means if xi observation, x1, x2, x3, all observations together come up to mean m, then first take x1, subtract mean from x1 plus subtract mean from x2, subtract mean from x3 and subtract mean from xn, and then add this. Now separate x1 plus x2 plus x3 plus xn and then separate m will be appear in n time m. Now we know that summation x is also n into m number of observation into mean, and nm minus nm equal to 0. That means when we subtract mean from each observation and add these all observation, we come up with 0. Now we study different type of data. When values of each observation is given, we call it a raw data. जब value of each observation is given, we call it a raw data. Suppose example is here, marks obtained out of 50 by 23 students of a class. So there are 23 students, or total marks is 50, and there are one roll number say 18 marks obtained, 18 marks, second 33, next 32, 29, 14, 28, 30, 23. These are number marks obtained by the student. Okay, we have written marks of each student. So this forms raw data. When whole observations has value and we have collected it and forms it in the form of a series, it calls a raw data. If xi observation has been, if some values x1, x2, x3, and this data has observed mean m, and a is another non-zero number. If we add this a to each observation, then mean will also added with this number. If we add a to each observation, mean is also added by a. Similarly, if we subtract a to each observation, mean will be also reduced by a. If we multiply each observation with a, mean will be also multiplied by a. If we divide each observation with a, mean will also be divided by a. Then if we add, subtract, multiply or divide each observation by a value, same value, then mean also will multiply, add, subtract, multiply or divide by that value. So if each value of a data is increased, decreased, multiplied or divided by a non-zero value a, then mean is also increased, decreased, multiplied or divided by a. Now we will study mean in three type of data. We have earlier seen raw data. This is also called individual series or discrete series. Second series, we have studied this raw data, and in raw data how to find mean. Now second is discrete frequency distribution. Third is continuous frequency distribution. Now we will find mean when data is given in these three different forms. First we have studied raw data, and in mean sum of values divided by number of observation. Now we will discuss discrete frequency distribution and continuous frequency distribution. Now when data is in form of discrete frequency distribution, in discrete frequency distribution we have given discrete variable x1, x2, x3, xn with their frequencies. Frequencies mean number of time a value appear. X1 has frequency f1, that means x1 is appearing f1 times in the data. X2 has frequency f2, x3 has frequency f3 and xn has frequency fn. If value is given with the frequency is given, we call it a discrete frequency distribution. Example, x value is 5, corresponding frequency is 3, that means 5 is appearing 3 times in the data. Next, x is 7, its frequency is 5, that means 7 is appearing 5 times in the data. 9 is value, 4 is its frequency. That means 9 is appearing 4 times in the data. So and so on. So when values with its frequency is given, we call it discrete frequency distribution. X is called discrete variable and as f is frequency, that means number of time a value appear. Now to find arithmetic mean of this discrete frequency distribution, having discrete variable x1, x2, x3, xn and frequency f1, f2, f3, fn. How to find mean? No, mean. First find multiplied each discrete variable with its frequency, corresponding frequency x1 f1 plus x2 f2 or f2 x2 plus f3 x3 and so on plus fn xn. First we multiply, then add these values. This is sum of all observation. In discrete frequency distribution, sum of all observation is f1 x1 plus f2 x2 plus f3 x3 plus fn xn divided by number of observation. Here number of observation, when we find a number of observation, we add all frequencies and we find all number of observation. So number of observation is f1 plus f2 plus f1 plus up to fn. So number of observation divided by number sum of observation divided by number of observation. This is mean in discrete variable, that we in short way we write summation fx divided by summation f. Here summation f mean number of observation. If we have to find sum of all values, we multiply number of observation into mean. Here number of observation means summation f. Whenever we talk of frequency distribution, in every frequency distribution number of observations can be calculated by adding all the frequencies. Now this is example of arithmetic mean in discrete frequency distribution. The example is marks is given 36, 42, 46, 45, 64 and its number of student mean frequency. 4 is time, 36 is appearing 4 times, 42 is appearing 5 times, 46 is appearing 7 times, 55 is appearing 6 times, 64 is appeared 7 times. Now we have to calculate arithmetic mean of the data. Now we will find by using table. First we write values of x 36, 42, 46, 55, 64 and then we find value of frequency, number of student mean frequency. Now corresponding frequency, first 4, 36 ke corresponding 4, 42 corresponding 5, 46 corresponding 7, 55 corresponding 6, 64 ke corresponding 5. Then we find table fx. How to find fx? F into x mean corresponding value of f into x. Now corresponding value of fx 36 into 4, 144, 42 into 5, 210, 46 into 7, 322. 54 into 6, 330, 64 into 3, 192. We will add it column wise. Note here we total, row wise total, we add frequency, sum of frequency 4 plus 5 plus 7 plus 6 plus 3, that come up with 25. Then we add fx, 144 plus 210 plus 322 plus 330 plus 192, that come up with 1198. Now what is mean? Mean is summation fx, that means 1198, total of a row of fx 1198 divided by summation f. Summation f mean sum of frequency, that is 25. So mean is equal to summation fx by summation f, that is 1198 by 25. From the table we will calculate the value and in formula we substitute these values. So we come up with 47.98. So mean of this data of marks is come up with 47.92. It will always lies in between 36 and 64. So it is the value that gives the, it's a center tendency. Now next, continuous frequency distribution. Third part is continuous frequency distribution. Here data is arranged in the form of classes. So for example, first class is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. That means if there is one student will go 5 marks, it will come between 0 to 10. 0 to 10 mean all values from 0 to 10. Second class is 0 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 5. These are classes. In exclusive classes, as in first example is of exclusive classes. How you can determine whether class is exclusive or not? Upper limit of a class is equal to lower limit of a next class. Exclusive class, in exclusive class, upper limit of a class, this is upper limit. In classes, this is lower limit, this is upper limit. Upper limit of this class, first class, is lower limit of second class. If upper limit and lower limit of next class are equal, we call it exclusive classes. In inclusive classes, in second example, upper limit of first class is 5 and lower limit of second class is 6, not equal. So, this is called inclusive class. An exclusive class, we add the boundary 0 will come in 0 to 10, but 10 it will come in next limit. That means in each class lower limit is included, but upper limit is not included. 20, if there is value of 20, 20 will come in, enter in third class. But in inclusive class, all limit upper or lower both are added, 0 and 5 both are added, here 6 and 10 both are added. So, classes can be given in two forms, inclusive class and exclusive class. In exclusive class 10 to 20, here 10 is called lower limit of class, 20 is called upper limit. Now, left side limit is lower limit, right side limit is upper limit. If we want to find width of class, how to find width of class? Upper limit minus lower limit of class. Any class given, we have to find width, we subtract lower limit of class from upper limit of class. It is also called height of class. And the third term is class mark or mid value of class. This is class 10 to 20. If we have to find mid value of this class, how to find mid value or class mark? We add lower limit and upper limit and divide it by 2. That means just as average. Lower limit plus upper limit by 2. Just for example, 10 plus 20 by 2, 15. So, 15 is class mark of this class. So, when data is in the form of continuous frequency distribution, in this type of data, first we must have given exclusive classes with the frequency are given. Now, what is continuous frequency distribution? Here classes are given and corresponding frequency is given. That is called continuous frequency distribution. One row is from classes 0 to 10 and corresponding frequency 3. That means 3 numbers lies between 0 to 10. 0 is included, but 10 is not included. In 10 to 20, 10 is included. 10 to 20 frequencies 5 means 5 values appears in between 10 and 20. Similarly, 10 20 to 30 has frequency 4, 30 to 40 class has frequency 2, 40 to 50 class has 3. Whenever we have given continuous frequency distribution, how to find mean? The next, when data is in the form of continuous frequency distribution, condition to find mean. First we determine, can we find mean? First we will check, first condition is classes must be exclusive. Classes must be exclusive. If inclusive, convert them to exclusive to find mean. Suppose this is classes, inclusive classes given 10 to 19, 20 to 29, 30 to 20, 39, 40. We converted it inclusive. How? With difference upper limit minus lower limit of second class, 20 minus 19 by 2, 0.5. So, we subtracted 0.5 to lower limit and add 0.5 to upper limit. In every class, we add 0.5 to lower limit, upper limit and subtract 0.5 to lower limit. We come up with 9.5 to 19.5, 9.5 to 29.5, 29.5 to 39.5, 39.5 to 49.5. So, this is the way how we convert inclusive class to exclusive class. Second condition is width of each class must be same. If we have to find mean, first we check whether the classes are exclusive, then it is okay, inclusive, convert them to exclusive. Second condition is each class width must be same. If different, we convert it to arrange into form when width of each class is same. no continuous frequency distribution. To find arithmetic mean in this continuous frequency distribution, we can find it with the help of three methods. We have given three methods: first, direct method; second, shortcut method;